Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 26 in our new, our improved, our exciting Arduino tutorial series. As you probably know by now, I will need you to pour yourself a large mug of iced coffee. No sugar, especially not those little sweetener packets. It is delicious and refreshing just the way it is. I need you to get your Super Starter Kit from eLego. If you don't have one, look in the description. Click the link, hook a brother up. 35 bucks, you get an Arduino and every imaginable component. And that's the kit that we're using in this tutorial series. Actually, it helps us if we use the same kit because our hardware is the same. Easier to play along at home if you do that. Okay, what are we going to do today? We are going to have more fun with photoresistors. In lesson 25, I showed you the band diagrams and the little bit of the solid state physics about how a photoresistor works. We saw that as light hits the photoresistor, it generates electron hole pairs. Those electron hole pairs make it more conductive. Therefore, the resistance goes down. The higher the light, the lower the resistance. And then if we create a simple voltage divider by putting that resistive sensor in series with another resistor, then we can create a voltage divider, read the voltage across that center pin, and then we can determine in the Arduino whether the lights are on or off or how bright they are. And we did it kind of a little warning signal where if the lights were on, everything was good. The green LED was on. If the lights were off, you would turn the green LED off and you would turn the red LED on. Okay, so this is what we are going to do today. It is going to be a little bit of a pop test for you because I'm going to ask you to do this on your own. What I want you to do is I want you to get, first of all, I need to get out of your way a little bit. I want you to get your Arduino, your breadboard. This is the passive buzzer, which you learned how to use in lesson number 24. Our 5K resistor and our photoresistor. This is what I want you to do. I want you to hook up the photoresistor in series with the 5K resistor. Remember, make that voltage divider like we did earlier, and then read the voltage off of that center of the voltage divider. And then I want you to hook up your passive buzzer. And then what I want is I want you to generate a pleasant and continuously varying audible tone that gives an audible indication of how bright the lights are in the room. Like imagine that you were blind and you wanted kind of an audible indicator of how bright the lights were. Now, I will give you a hint. In order to do this correctly, you are going to have to use math. Yes, I know I'm getting a lot of thumbs down on these videos because I'm trying to get you to think. I want it, guys, it's great that I know how to do this, and it's great that you can watch me and copy what I do, but I need you to start doing things on your own. And so what I'm doing is I showed you how to do A, I showed you how to do B, and I know with A and B, you can figure out C. In the earlier lessons, I have given you enough information where you can figure out how to do this. Okay, so I want a pleasant tone. Dark is on one end, and then very bright is on the other, and all light levels in between smoothly vary the tone. Okay, go do that and then come back and I'll do it with you. But really, man, you're going to get stuck, but figure it out. Don't watch me do it. You get it working first, and then you go down in the description and said, I made it work by myself, and then I will give you a gold star. Okay, go do it. All right, are you back? And you want to watch me do it. And now let's see if you did it the same way I did it. Would love to get comments from you guys down below. Let me know if you did it this way, if you had a better way to do it, or if you did it differently. But let me start by hooking the circuit up. So we're going to start with the voltage divider. I'm going to put the 5K resistor between column 10 and column 15, between column 10 and 15, and then comes the photoresistor between 15 and 20. Okay, and what is key here is that the resistor and the photoresistor share a common column there at that connection. All right, then the top or the left of the resistor there, that leg of the resistor, the left leg of the resistor is going to go to 5 volts. All right, then we need to ground the other end of the photoresistor, so the bottom of the photoresistor is going to go to GND. Have your photo detector up pointing towards the light. Now we are going to hook up our passive buzzer, and so we are just going to choose to appropriate. And remember, the buzzer has a polarity, so what you need to do is make sure that the positive polarity has the little plus sign, the little plus symbol there, that will go to a digital pin. I think I will use pin 8 today. All right, and now the other leg, the one that's not marked plus, needs to go to ground. And so there is another GND over there by 5 volts. And I think that I have this thing hooked up. All right, now to make it work, we need to do a little math. And if you remember, you need to do the measurements in your room with your setup because your measurements might not be the same as mine. But when I came in the last lesson, oh, I forgot one thing. We need to measure the voltage at this voltage divider. So right here in that column 15, I need to take that signal off. Let's see, maybe I can zoom in here, give you a little better view. All right. So do you see this part of the circuit where one leg of the photoresistor is hooked to the resistor in that column 15? I need to put a wire in that column 15 so I can snag. I want to snag that voltage and I want to bring it over to pin A0 so I can read it. Okay. So that is going to read that voltage. And again, this is very, very, very similar, kind of identical to what we did in the most excellent lesson 24. And so this is all hooked up now. This is all hooked up. But now we have to do some math. And what you need to do is you need to go in and you need to read the signal off of that photo detector. And what I could call that is, I could call that like, let me now switch where you can see what I am writing. I need to zoom out. Okay. And remember when we did this in the earlier lesson, let's call it light val. That is the value that's coming off of that when read in A0. What we found was that light val was 750 when the light was on, right? When the room lights were on very brightly, it was 750. The light val was 200 when the lights were off. Okay, so those are two numbers that are very important, 750 and 200. Those are sort of our endpoints. Also then, do you remember when we were doing the passive buzzer? What we could see is that a really nice tone started at about 1 millisecond, and a really nice tone on the higher end was at 10 milliseconds. All right. So if I want to go smoothly between these values, what I can say is that when the lights, let's see, when the lights are on, this is what I'm going to read. I'm going to read 750, and then what I want to generate is 1 millisecond. Then when it's 200, I want to generate 10 milliseconds. So this is the way you got to do it, right? Again, this is a line, and I'm hoping you guys are getting comfortable in doing this because You can't just wing it. You really need to do the math. So let's draw our graph. And what is the independent axis? Is the horizontal axis. The independent variable here is what? Light val. Light val. That is what we measure. And then what do we want to generate? What we want to generate is the delay time. So this 1 millisecond and 10 milliseconds, that's the delay time. So what did we say? Well, I can't remember exactly what I said, but let's say that if I read 750, I want to generate 1 millisecond. So if I come over here to 750 read, I want to generate 1 millisecond. So this is the point, 750 and 1 millisecond. So if I read a light valve of 750, I want to create a delay time of 1. Then what is the other point? The other point, I did this backwards. I need to use the lower one, 200, because that's further to the left. So 200 on light valve would generate 1 millisecond in delay time. And then a light valve way out here of 750 would generate 10 milliseconds. So this would be 750 and then 10 milliseconds. All right, so I've got 2 points now, and I can draw a line between them. I can draw a line between them like that. So let's create our 2 points very clearly here. I've got the point 200, 1, and I've got the point 750, 10. I need to find the slope of that line. The slope m is going to be equal to y2 minus y1, which would be kind of delay time 2 minus delay time 1 divided by light val 2 minus light val 1. Right, normally in a line you think of y2 minus y1 over x2 minus x1. Well, here we're just using delay time 2 minus delay time 1 over light value 2 minus light value 1. So I want you to see that a line actually makes sense when you're doing, real systems like this, and you can't work this problem if you don't do the math. So now, what is the slope, or what is the point slope form of a line? It is y minus y1 is equal to m onto x minus x1. And for this case, what I would have is my y value is delay time. So I would say delay time minus delay time 1 is equal to m onto light val minus light val 1. All right, so now let's go ahead here and calculate the slope. So the slope, let's calculate the slope here. Delay time 2 minus delay time 1 is going to be 10 minus 1 over, and that's going to be 750 minus 200, 750 minus 200. And so the slope of the line is going to be 9 over 550. I hate doing this in my head, but I think that's right. Now we've got to take this and we've got to put it in for slope here. And we've got to put the numbers in. So I have delay time minus delay time 1. What is delay time 1? It is 1. Delay time minus delay time 1 is 1, is equal to slope, which is 9 over 550 onto light val minus light val 1. What is light val 1? Light val 1 is 200. Okay, so now what do I have? Delay time. I'm going to add the 1 back over here, and I'm going to have 9 over 550 times light val. Now I'm going to distribute this over to here, which is going to be minus 9 times 200, right? I'm distributing this over 550, okay? And then I still need to add the 1. This is the equation that I need to program. And normally you would work this out and combine those, but we can just put this whole equation into Arduino. So let's bring this back, and now let's see if this crazy thing is going to happen. Did you guys go in and do your math like I've just done? That is the way that you have to do it to make it work. So let me call up Arduino over here. And let me see if I can get a nice view for you to see. All right, that's not too bad. So now, what do we need to do? Well, we have got a pin that we're doing. We've got the light pin, right? So I'm going to have int and light pin, and that is the pin that we are reading from this light sensor. And so that was a, what did I say, a 0? And I think I better make it a capital A0. All right, then we have an int, and we have a buzz pin, and buzz pin was pin 8. Buzz pin is 8, so I have my 2 pins set up. I don't think there's any other pins that I need, so I'll come in now and I will do my pin modes. So pin, excuse me, pin mode, A0 is a what? Output, all caps, output, all caps. All right, pin mode, buzz pin is an output. All right, so I got my pin modes done. Now what do I want to do? Well, I need to read the value that is coming off of the sensor. That will be light val. So I read, and then I need to calculate delay time, and then I need to use delay time and send that in the delay that I use on the buzzer. All right, so what's the first thing I need to do? I need to read. What do I need to read? I need to read light val, which means I need to declare that. So int light val. And I don't put a value there because we're going to calculate that value. And then also I need an int, and that initially we called it delay time. So delay time. And I will calculate that. All right, so we come down here. What's the first thing we do? We read light val. So light val is equal to analog read of what? Of light pin. So we're going to read that value that is coming off of this sucker. Okay. Now, is it light val that I want? No, I want delay time, so I have to calculate delay time. So I will call it delay time is equal to what? Open parentheses, 9 point divided by 550 point. To make sure that we are doing floating point math, you've got to put those points in there. And then times what? Light val that I just read. And then I need to subtract, again, use floating point math, 9 point times 200 point divided by 550 point. All right, and now I need to add 1 point like that. All right, now what do I do with this delay time? Well, that sets the tone for the buzzer. That will set the tone for the buzzer. And remember, the buzzer is on buzz pin. So now to buzz, what do I want to do? Digital write, buzz pin high. How long do I leave it high? Well, I leave it high for delay time. Now what do I want to do? I want to turn it off. Digital. Oh man, I forgot my semicolon up here, didn't I? Were you guys yelling at me? Don't forget your semicolons. Okay, digital write buzz pin low. And then what? Delay by delay time. So that's going to make it buzz, And the noise that it makes buzzing depends on this delay time. And so as the light value changes, this red light val, as I change the brightness of the lights, light val is going to change. And then that's going to calculate, once I have that light val, it's going to calculate delay time, and then it's going to buzz at that delay time. So when I download this, with a little luck, we should hear something. We should hear a tone. Okay, better get a strong shot of coffee on this one. Okay, I need you guys to hold your breath. It downloaded, but I am getting no noise. I'm getting no noise. Oh, this is not plugged in good. All right, what did I do wrong? Buzz pin is what? Buzz pin is 8. That is very good. Buzz pin is 8. All right. In a case like this, I am hooked up, I do believe. Let me make sure that this is, yeah, that is plugged in. So what am I checking? Making sure my buzzer is plugged in. My buzzer is plugged in. It is plugged into pin 8, and I do have a ground. So all of that is very, very good. Have you guys seen where my problem is? So the only thing I am really having, let's print delay time and see if it makes sense. So here we're going to go serial.println, and then we are going to print delay time like that. And so let's just see. Guys, really, I did not mess this one up on purpose, but when something goes wrong, I want you to learn how to debug. And so this is debugging. I'm going to put that down. That came down. I need to find a different view where you can actually see the serial monitor. Let's see. I've kind of gotten things locked up here a little bit, but let's see. Let me see if I can get that serial monitor. Okay, there is the serial monitor. Is it printing anything? It is not printing anything. Serial print line delay time. 9600. I didn't set up. I didn't turn on the serial monitor. Serial dot begin 9600. All right, so now at least I should be able to print out that delay time and see. Okay, looks like that downloaded, so I'm going to come over here, and I am not getting good values here, so let's see what is wrong. Okay, if you're going to play that way, let's just come in and just flat out do light val, because that should certainly work, right? Because I'm just reading light val and printing light val, so let's try that. Okay, that looks happy. Open up the serial monitor. So you see, I am not reading off of here. It is like the program is not running. My baud rate is 9600. Let's make sure that I can see the, let's see if I can get a better view for you guys. Okay, you see nothing's happening on the serial monitor. So what I need to do is I need to try to understand. I'm just printing out light valve. It's like the program is not running. COM3 still looks happy. I'm on an Uno. I'm going to download this. I'm just not sure, pin mode, how this thing could be hanging. It should, I do a light val as an analog read, calculate this, and delay time. I wonder if like delay time is some crazy wrong number. So I'm going to comment out this part of the code, because if delay time is a crazy wrong number, then it could just be getting hung there. So I'm going to switch to an even better view. I think that you can see. Let's see if that one will. I need to get the one that shows you the screen. This one. Okay. So I'm going to come up here and I'm going to comment out. So I'm going to comment out that region so it takes those lines of codes out. And now when I download it, hopefully I will see a value. When I call up the serial monitor. Okay, yeah, so that is reading values. That is reading values, but the values don't make any sense for light val. So let me see. I have this whole thing hooked up into that center. I do have 5 volts coming in. I go across 5K. Did that make a difference? No. That plugged in. It is as if my circuit is not connected. And then did I do A0 on the light pin? A0 is an... Ah! Why weren't you guys yelling at me? I made A0 a what? Output. That is an input. I did not do that one on purpose. And so let's change that and see what happens. Okay, now if I come over to this view, you can see that we are getting good numbers from the serial monitor. Okay, so I didn't do that one on purpose, and I didn't mean to waste your time, but do you see how I go through the debugging process? First thing I tried to see was it a circuit problem? Then I'd start looking at the code, and then when I look at the code, I simplify the code by taking off these things, all right, by taking off these things. And now let's go back and let's print out delay time, and let's see if those make sense for delay times. Delay time should be between 1 and 10, right? Because that's what we were trying to calculate. So that's 1. And as I get dark, it goes up. Yeah, so this is working like we would expect. So now what do we need to do? We need to come back in and we need to put these in. What is that nonsense? Somebody is trying to call me. But I am busy, so I will not take the call. So we will say uncomment, right? We're going to uncomment that region. And I have got to make that blasted thing stop. All right. So now I'm going to put this over here so we can listen in. Okay. And now I'm going to download it. Do you hear that? I hope you can hear it. It is working perfectly. Okay. Let me go turn the lights off, okay? You keep listening. I'm turning the studio lights off. Are you guys able to pick that up? Very nice. Boom. We have an audible signal that is smoothly switching as the light goes from full off to full on. All right. Guys, we really, you know, I feel silly when I make a mistake like that. But the thing is, you will, believe me, you will make mistakes when you code. And the thing that you've got to do is you've got to learn how to troubleshoot. You've got to learn how to debug. So let's review. Maybe the most important thing that you learned today is, well, first of all, math works. This work that calculating that delay value based on the light value allowed us to control this smoothly. The math works, but you can't do this unless you do the math. And so whenever you have a problem like this, I want you to start thinking about lines. The slope of a line is y2 minus y1 over x2 minus x1. But your y's and x's depend on real values. You know, your x's is something you measure, and then your y is something that you're trying to calculate. You calculate the slope, then y minus y1 is m onto x minus x1. You come up with the equation of the line, and then you can get this magical performance in your programs. Then, when this thing didn't work, the first thing that I thought is, well, I could have hooked to a wrong pin. I could have had a loose connection. So I fumbled around with the circuit, but it seemed like the circuit was right. Then I came over and I looked at the code, and I thought, well, it would be very easy to have a mistake in this equation, so I want to just print out that value to see if it's the anticipated values. Turned out it was the anticipated value, but I wasn't getting a buzz. Why was I not getting a buzz? I was not getting a buzz because I had set this up wrong. I'd done the pin mode as an output instead of an input, so all the numbers that I were reading were in fact very wrong. Okay, guys, man, put comments down below. Did you do this without my help? Or when you followed along, did you see the mistake I made? Were you screaming at the screen about the mistake I made? When you did it yourself, did you have similar mistakes? You know, share. Let's get a little bit of discussion, a little bit of dialogue going on these things. Okay, this is Paul McWhorter from TopTechBoy.com. I will talk to you.